Hello. Well, I don't know if it works. I don't think the microphone is working. Set up your speech recognition. No. I had a sample here. Kinda. Hello, 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 hello. Hello, hello, hello. Hello, hello, hello. Hello, hello, hello. Okay, now it seems to be working. I'm a streaming noob. I don't really care. I should get like a AI bot thing on screen, and I can do all these fancy things. But maybe I'll do that on my other computer, on the other computer, and make it a restream computer. But I'm planning to make a box. Alright, so I have to set up my other computer. Maybe I'll do it on that one, but make it what do you call it? Audio amplifier. I mean video extruder. There's some fancy name for it. So let's look at some documentation first. Yay, this is the fun part. I found this inside the NDK9. So let's see what else we could find like this. I was looking through the NDK9 trying to compile it for the older device, and then I kind of said, okay, this is over. My Android day is coming to a close. The best thing I can do is do a fun Android Studio tutorial, and even that I can't prep for it because I'm not ready. So I might as well just look at the other code, see what I did in C++ on the PC, and I kind of got into a good thingamajigger. I got my map development. What I don't have in this is the random time like I do on the other one. So I got the scroll to work. So maybe we'll just port the scroll. The scroll was a pain in the death. And it was terrible. And then the mouse on the PC was terrible too. And then something else was terrible. So I'll try to use the version I've been using for tutorials, and I'll maybe replicate it just so I have another backup copy. That's a good practice. So I have all these backup copies, and I'm starting to get confused which backup copies go where, so I might have to subfolder this. And there's the game controller. I'd like to work on that. The game SDK. Why does this have to be above this? Okay, fine, let's just patch it while we're at it. Update and restart. Oh yeah, I do want to get a watch. And I do have a few devices that are Android TV things. I want to mess with those too. So that'll be like upcoming videos. Please subscribe or something. Gemini code transformation transforms. Oh, let's take a look at that. Let's update the stream. I'll just make it cool. And then I'm not using the camera. I'll just use this as the media source for when I do little stuff. And I'm working on, well, I have two screens with the other screens for the other Apple computer. 3D positioned audio. So basically, there's two very big standards. There's actually some more, but the two primary ones I focus on, or at least I'm trying to, is DirectX. No, I'm kidding. It's not direct audio. It's I actually got into OpenSLES first on Android, and then I just got it to run on the PC for MyGwin. So MyGwin has been used, I guess, also for Android development, but I've been using it primarily for Glute, old school Glute. People frown upon Glute and MyGwin, and they tell me, why are you doing this? And we see that it was quite successful. That, okay, this is the minimum, this is the billing one. They do want to load up the billing one. Alright, so restart, your ID is ready for update. Yeah, make sure taco shop is open. That's like our primary fuel right there, tacos. Let's see, and type in something like Android Studio Gemini, because generally I have a paid account. I don't know, I think Google tried to bill me. My credit card just went down today. I'll figure that out tomorrow maybe, or tonight. Gemini and Android Studio. Yes, there's an extra page. Alright, so I've been using Gemini for a little while now, and it depends how you use it. So I'll show some demos. This is how I kind of use it. I usually don't do it like that. I'll just do Bard, because I started using it during the Bard days, and I liked Bard 1.0. I talked to him about some interesting topics, starting from default thought thinking, critical thinking, long-term thinking. Well, deep thought thinking is kind of the same thing as long-term thinking. Reflection, current world events, religion, coding then later. And I was really surprised what we gave in coding. So okay, that aside, so we got Gemini Advanced, right? Okay, Flash Thinking Experimentals. So let's ask a question like this I usually ask, because the Bible is the biggest, like, it's not the biggest book, it's not as big as like War and Peace, for example, but usually he gives this answer. This is the most common answer I've gotten from him, and sometimes I'll get resources like Bible Gateway, which is a very popular site. Alright, so, and then we ask him, tell him, hope you're good, and just kind of get his mind kind of warmed up for this conversation, because it starts him out kind of in this biblically friendly way. So this has power. It'll trick the prompt too, I think, because yeah, like they disabled him saying this for a little while. So let's see, how do I use Gemini within Android Studio? We'll play a little down by misspelling things because I'm too lazy. I put Gen in mine. Launch view, tools, Gemini. Sign up with your Google account. Right click on code editor, access Gemini's code generation transformation features. Hit highlight by notifications. Where's the little talk button? Did they remove that?
Integrating Gemini into Android Studio enhances your development workflow with AI assistance.
How do we change the voice?
Here's a breakdown of how to use it. Key features. Chat interface. You can interact with Gemini through a dedicated tool window within Android Studio. Ask questions, request code generation, and seek solutions to errors. Code generation and completion. Gemini can generate code snippets based on your prompts. It offers AI-powered code completion as you type, providing suggestions in real time. You can select code within your editor and ask Gemini to modify or optimize it.
IntelliSensible.
Error troubleshooting. Gemini can analyze error messages and provide explanations and solutions. Contextual awareness. Gemini can access context from your code base to provide more relevant and accurate assistance. Getting started. 1. Android Studio version. Ensure you have a recent version of Android Studio, Jellyfish or higher, installed. Using the latest Canary version is recommended to have the newest features. 2. Launching Gemini. Open your Android Studio project. Go to View, to Tool Windows, to Gemini. Sign in with your Google account. 3. Using Gemini. Chat window. Use the chat window to ask questions and provide prompts. Code editor integration. Right-click within the code editor to access Gemini's code generation and transformation features. Highlight code and right-click to ask Gemini for modifications. Pay attention to the AI code completion as you are typing. 4. API usage. For more advanced integrations, where you want your application itself to use the Gemini API, you will need to look into the Google AI Client SDK for Android. This is useful for prototyping. For production-level apps, it is recommended to use Vertex AI in Firebase. Important considerations. Accuracy. While Gemini is powerful, always review and test generated code before using it in your production applications. Privacy. Be mindful of the code and information you share with Gemini. Updates. Gemini is continuously being improved, so stay updated with the latest Android Studio releases and documentation. By following these steps, you can effectively utilize Gemini within Android Studio to enhance your development process.
This one doesn't have a docs folder. That's unfortunate. Damn it. Alright, so what I can think of is like, let's go version hunting for a second here. This is critically bad. Okay, 19, there's no docs folder. 21, there's no docs folder. Yeah, back in the day, they used to have this whole documentation like slapped right into the NTK. Now they don't. It's annoying. Let's see, 19 sources, Android, native glue. So when you try to build these like really native-ish apps, you learn a lot about how to manually construct the application and like what goes into it and what the device actually does, like decompressing the APK. Yeah. Check disk space. Make sure. Okay, we have some space. It's not that bad. Just get the update. It sucks. It keeps doing this to you until you run out of space. Oh, whoops. I turned up the wrong audio. So I want to say this is all crap. All I care about now is tacos. Let's see. The project that we need is Android Play Store. Was it My Game? It was one of these. It wasn't My Game though. Android Squirrel Game 1. That's the one. That was the tutorial video. No, whatever. Okay. I don't see it here. I opened too much shit. Yeah, there it is. Let's open that. Well, sometimes you gotta really wait for this thing. I used to truly hate Android Studio. It's so bloated, but they've made it faster. Or maybe my computer just got faster because I upgraded to a Xeon from like a quad-core i5, and like the nice thing about DDR4, it's a little bit cheaper than DDR5, and if you could afford it, just like spam RAM and waste all your money. On RAM first. CPU, you could always get a Xeon, get a Chinese board that supports it. And we still have a good workstation. It won't be like the best megahertz, and you won't have the best GPU. I have like second-hand GPUs, but they're okay. I don't really sit there and stream Call of Duty. I mean, I find the game fun, but it's just like, no, it's kind of like brainless lame. It's fun, but all you're doing is like looking for those crazy sniper shots, or I would just go demolition and ambush people. Whatever. It's stupid. It used to be fun in the good old days, but now it's just kind of like, oh, everybody's a troll, who cares? Alright, so how do we do this? Tools, Gemini or something? I don't think we even need to do anything. It already works. It's right here. Oh, login. Oh yeah, we have to like log in. We have to authorize this garbage. Let's log in with this, because I have the advanced. Just so we can see the full might of the Google side. Log into Android Studio. Use your Google account. Just to unlock the following services for your Android app. Yeah, let's just click on this because it's more prevalent. All tools for Android Studio documentation. Oh, I don't want to read any of this shit. Like, as soon as I see a page like this, I just want to alt-tab. Open another tab. The Cloud Shell for IntelliJ plugin is now supported in Android Studio. This will replace the Google Cloud Tools for Android Studio plugin, which has now been deprecated until somebody got fucked. Please submit feedback feature requests through Google Cloud Code GitHub page. Okay, then yeah, we open another tab, and you get taken to one of these. Fucking like everybody's pissed. And then they just close your request. And there's nothing in the README. See what this says. It says some stupid crap. Just go to Google and you'll die. Alright, Firebase. New mobile backend. You could use Firebase. I don't want to use Firebase. I remember it being grim and stupid. Like, oh yeah, just use this Android. Oh, that's actually kind of good. Kinda, but what if I have 4.4, which I'm trying to support because I'm an idiot and I think Raspberry Pi is cool. Well, on Raspberry Pi you could actually install Android 9, and it's basically like 5.0 or something. Like 5 was the real big update, so was 4.4. Somewhere between like 2.2 and 4 was like the OpenGL ES 2.0 jump. And we implement actually OpenGL 3 here, and I'm trying to like target 2. So I don't know what I'm talking about, but it's okay because I think if you implement a basic 3 like this one does, it can go back to 2 as long as I think I don't use certain things. Like, let's ask it. Authorized. Gemini and Android Studio is offered no cost while preview is currently available in select countries. Okay, next. Privacy services, next. I agree, must 18 years old or generative additional terms of service, and next. Use context from your projects to improve responses. Do not context any project. Ask to decide per project. To finish, confirm pricing. You like any of these tools soon. Okay, I want it to be per project. Certain projects I know what I'm going to do. I'm going to go in there and fucking snipe something, and it's going to get in the way. Oh god. I found a great old video today. It was a really important Keystone video. This one.
Then it becomes impossible to deal with library projects.
Oh yeah, I didn't watch it all the way. I'll watch it tonight maybe in bed. This is a real like brain grinder.
Whether they have the same package name or not, depending on free versus paid or not, and it will just my thing.
There's like no comments in this video. That's the funniest part. Nobody commented on this. They're like, that's interesting. I really regret I came to the table too late. This is exactly what like a lot of people are like 1 month ago, where it all began. I had to check if I had 1.5x on it.
And of course you want to have different code in those, right? The free version will have some code specifically to free and the paid version to pay. So for each of those you get a new source folder as well. And because you want to test it separately, you get a separate test folder.
Back when it was paid. That's funny.
And you know, if you have a free version that's supported by ads, you want to add.
Alright, more. Remind me tomorrow. Yeah, that's always the best answer. It's like 2 days later, you're still there coding, and it pops up again, and then you click on it by accident because you're so sleepy. Alright, let's see. Let's hit finish, I guess. What is composable? What's the relevant recycler view in compose? Create a person data class in Kotlin. How do I test an Android app? Let's ask us something stupid. Since you do the training. Yeah, shopping cart thing would be cool actually though. Unit test thing. And Makito when? Oh, it's actually using these. I had to use those to like make my project compile. I couldn't figure out why. I had some other kind of issue. Alright, what is it called? Let's see if it can answer this for me. I believe I was doing that in the other project. Maybe it wasn't this one. No, it was in this one. And it plays a sound. So you got mixer object, yeah. Create the engine. Yeah, I remember doing some of this shit now. Damn it, it sucked. Hello?
Hey, can you ask Mom what medicine she needs again? I tried calling her, but she didn't answer.
Oh. Okay.
What was it?
I have a fart for you. I have a fart for you. Stupid. So I find like the biggest part of this is naming file convention. It's just importing the assets. All these game engines have all this asset import, but it's always the same. It takes the same amount of time. The most terrible thing about game development, assets. And it doesn't matter if your game engine is not Unity or whatever. It's actually easier in your own game engine by a little bit, but you have to know what you're doing and how it works a little bit. sometimes you could just forget and just dump them in there after you created your engine's asset thing or because you're always, all the assets in every game are really the same thing. They'll be like the same, or like they should be, because how it compresses it. So really, this should go into build. No, it's not going to go into build, obviously. It's going to go into source, main res at some point. I believe, wait. Oh no, in assets. It's going to go here, right? So we have already one sound.
Hello, I'd like to eat burgers because my farts are not good enough.
Yeah, so I need a few more sounds just to kind of distinguish what I'm doing. So we have, so let's paste it in here. Paste, right? Yeah, so it'll move the file into assets, push it to the device. Alright, so what is he explaining here? After you've registered the buffer, wait, let's go all the way down and then go to the other question. Because he had 5 things we had to do first. And I think these 5 things are done. Let's just read them out loud. It helps. Create the engine. SL create engine. Realize the engine. Get the result for a call of realize. Get the engine interface. Get interface, the engine object, and have the engine object. Alright, so 3 is engine object, is getting its context. 1 is engine object creating its context. 2 is realizing, so some sort of initialization to the context. 4 is get output mix. That is the output mix object working with the engine object to initialize a get, or just to get pumped into the system. And then realize output mix is getting the mixer to instantiate, I guess. They call it realize with this audio thing, or with the OpenSLES, whatever. Okay, I understand you'd like me to elaborate player, set a buffer queue, etc. Part of here's a detailed breakdown of how to create audio player, set up buffer queue and magic plan parcel with a code examples and explanation. Data source, you'll define a source of audio and data and buffer queue, meaning you'll be feeding audio data to the player in chunks. Data sync. You'll define audio will be played. This typically is output mix created by earlier contains device, output device, player creation. You'll create audio player object, specifying the data source and sync, and requesting necessary interfaces. Buffer queue setup. You'll configure the buffer queue, including registering a callback function that will be called when a buffer has finished playing. In queuing buffers, you'll in queue add data buffers to the queue. Starting playback. You'll set the player's state to SL state. SL play state underscore playing to begin playback. Callback function will be called when the buffer is not playing. This is function you'll typically fill the buffer with new audio data and queue the buffer again. Looping. The process of called filling and queuing buffers will continue creating a continuous stream of audio. Yes. Before I want to ask it the next question, should I put this on a thread? I don't want to because it'll just convolute me. I just needed to get really basic with it. Because right now I have a broken system because it just plays one sound and loops and doesn't stop. There's no callback. So I've learned a little bit just from reading this. Well, I learned a few more other things maybe. Like there's a loop queue, a buffer system, a player, and then a mixer. And then the mixer, so you can play multiple sounds at the same time. What I already picture in my head, just from like doing electronics audio, is like the mixer is taking a bunch of phone jacks, and you have to have a bunch of phone jacks, audio jacks, and then it comes out with one audio jack and 2 speakers. That's like your base setup. I mean, obviously there could be a center and a back and front, and like, or 8.1 setup as they call it. Most setups are 5.1. So I should just visualize that just for fun. 5.1 audio versus, let's do versus stereo. Really what I wanted to do so this is your classic 5.1 setup. And where does it stop? It never stops. You could always have another mixer. You have multiple mixers and just keep going. Yeah. Sounds fucking crazy. You got your little beat subwoofers, main subwoofer, 4 big ass speakers, tweeters. So there's 3 main components. It doesn't have to be that much though. So speakers play the mid-range, tweeter plays the small, and the subwoofer plays the kind of like the bouncy. So you got these things. And then, yeah. So that's why I kind of always hated audio. It's just because I would just go off on a tangent every time. And not that I hated it in particular, I just wanted it not to like convolute me, and I just go off on a tangent. And I'm trying to figure out like, oh, maybe if I can manually source code all this. It's like, no, just follow their little diagram. Alright, so the next part is knowing that the megahertz of a sampler, which is just a fancy word for texture. Well, no, yes, and no. It's just like the wave is going at this hertz, some sine wave. Well, it's not a sine wave, it's a wave of the speaker bouncing up and down, the 2 magnets. Number of channels is the number of speakers. It's also the number of channels in this context. So configure your audio source. Q. Simple buffer Q thing. So essentially, imagine you're setting up speakers in a room, and we're completely brainless. Like we have no IT support. The capability, our wires are bad. We don't know if we plug in a wire, if it'll matter, plus minus. And I guess in audio it does matter because there's always like a red wire and a black wire, and people screw that up because a lot of times audio wires do not specify. I don't know if it matters, but I should look that up. I think it doesn't. It does. Yeah, this is the tangent I'm talking about. This polarity of speaker wires matter. And I should know this by the laws of physics, but I know they've made things now that where it could be idiot proof. You could use diodes to somehow just switch the polarity, but that's not a good thing. Are speaker wire polarity sensitive? Answered, yes, speakers are polarity sensitive. This means that they have positive, negative terminal, and connected audio source can affect their performance. If connected in reverse, negative to positive, speakers will be out of phase, which can distort the sound. Oh, that's cool. And electrical current, positive, negative pressure variations travel from microphone to speakers, then out. Yeah, speakers then out to your eardrum, producing sound, reversing. One or more elements can cause a matter of issues. The additional audio quality to distortion seem to come somewhere else entirely. Yeah, so if you're installing audio to your speakers in your car, and they always give you these wires that you can't tell what the polarity is, especially if it's a long wire, you're fucked. And you have to be a OCD and like follow the entire wire, label it. That's how you really do that. But configure your syncs. So I'm talking about like 2 different things at once, but it's kind of related. Okay, sample format. So bits per sample. So this is the digital part of things. It's like look up digital amplifier digi key by 4 Raspberry Pi 0. Yeah, let's just go complete hacker style with this. And yeah, the cost of these is gonna matter about that chip, and it's probably that little thing right there. ADC converter. So on the computer, a lot of times we don't really care. Okay, wow, this is $300. This little fucking board. Oh no, this is a fucking M2. What the fuck is this shit? It's a fucking cell phone thing. Had multi-band Snapdragon X55 board. Yeah, this is a little bit overkill for what we're trying to do here. Onboard UART power reset pin. Does it have multiple of these modules? M2 key slot. Oh, so it has. You could put your SIM card right there. USB 5. I mean 3. Sorry, 5. Earphone. So this thing is like designed to blow up your eardrums from watching TikTok. Oh my god, how this looks like a fucking radio jammer thing. And it has 3G too. It's dial up. This is a cool thing. Yeah, and you gotta put a freaking heatsink on it, obviously. You could just scrap one from like an old video card. The specifications from this, if you could read and understand and enjoy them, it'll make you smarter. Okay, so I mean, obviously the sound here sampling is not going to be sampling like that chip does, but that kind of explains some of it. Okay, so the speaker front we want, and the speaker right. So this is basically your earphones, right earphone, left earphone. Because most people wear earphones nowadays, since we've become a society where, you know, like having big speakers like I did back in the day was stupid now. You're just causing yourself problems. Configure audio sync. Output mix. So output mixer, output mixer, output sync, null. IDs, buffer queue, request, create audio player. Yeah, so whatever that means. So let's just say we got a little cassette player. I'll just reference it to something. Let's check our source code here. Let's just do a bunch of finds. Because I did a lot of this last tutorial, and I've actually forgotten. I kind of have it in my brain somewhere in the back right now, but I've been through so much other fart code things, like trying to get, for some reason, sampler diffusion to work, and other source stuff, and all of a sudden things get clouded. But it's really good to learn this way. Like, I'll take 2 days on that and 2 days on this. That way I get like some of it done. I also gotta take 2 days on electronics and just sit there and program Raspberry Pis to do a few other things that I remember I had to do. Like, you could make it a speaker player, Bluetooth or something, and you could make it play through the radio. There's some really neat little projects, and you could even not do any hats and just find code and do it that way, but usually you do it through finding hats, and yeah, like, so you find all the cool code bases. So we got release Kulo scroller. So this is the old code. I just kind of commented out using the FTF. Okay, best thing to do is run this just to kind of get a landscape of how it worked. I forget like how it works. I think, yeah, I have to press the button and it plays. And I embedded everything inside the render function, which is bad. So we should move this like that. That'll be our goal. Get this to work inside a different function. Okay, so the character moves. So it's the green button. So when I hit the green button, which is just in this create function, what I should do first is backup time. And we could make it so that every time I press a button, or like jump, I'm trying to think if jumping works in this. And then it needs to have scroll, so there's a few things I can fix here. Should make a subfolder for just this. I don't know how to spell tutorial. Who cares? Something like that. I'll just cheat and dump this in there and just create I just created a bigger mess than I needed to. Okay. So play sound. Here it is. Register the buffer queue callback and queue the first buffer. Start playback. This is what we're doing here. Set player state. Set player state. Yep. So it's better to like wrap this function. And also, let's go find play that. The way I've seen it done in different game engine is that they would always call upon the sound name when they're playing the sound, which I found to be wrong intuitively, because you should just call the ID or something. Like, you have to reference each resource like this, but because you can't use those like array style string format, print format, sprint format ways. It's cool, but when the compressor like compresses the APK, you're gonna get in trouble. It's gonna like butcher your code and like do something unexpected, and different devices will have different results of error. Yeah, so you will die. Alright, so what this does is NIT sound. It opens this asset, right? And this is like loading a texture. Just pretend we're loading a texture. I've done this in the other tutorial where I had to switch up the texture code to use compressed texture. Oh, and here we're not using compressed texture. We could add that too, but maybe not today. Basically, you just copy this code and then you re-code it to be like old school C versus this new style C++. Bloated where auto everything things. It just looks like Java. It looks more like Java than Java does, and then it's like confusing because then you have things like Kotlin that are in the mix of this. Like they're trying to just put like authoritatively enforce Kotlin on us, and I'm like, I refuse to use Java. How are you gonna make me use Kotlin? I learned some of it, and then I just like, wait, this sucks. Like, if my device is gonna save power and it's gonna run on this like bloatware thing, yeah, I don't know. Garbage collection is like good business if you get paid for part of the amount of garbage, but when you're generating it, it's bad. But I don't know. We'll end up using it eventually anyway. So we make the engine, and that's a little problematic here. I would change the order of this. I would first instantiate the engine. But here you can see what I was doing. I was just like, because I had problems with this initializing first. So we create the audio player, we realize it, right? So let's go back to this. Yep, realize the player. Yeah, and I had notes of this too. And get the player interface 6. Create the audio player 4. So this is how you do it. You just make really good comments, because later on it helps you at the time you're doing it to memorize for future reference, so you can be very stable coder later on. You're not just like, oh, in dynamite memory I can't figure it out now. Configure the audio source. Create audio player? No. What is this? Configure the audio source. Start. Oh, okay, so this is doing fread. This is really fread. Oh, no, maybe it's not. It's because we got the file descriptor. FD stands for file descriptor. There's like different file descriptors. There's data location file descriptor. There's like other file descriptors here. I've read about the in the Mac OS and Linux programming book about these file descriptors. I was just copying the book at that time, and yeah, so it's a good book. It describes where some of this comes from, and like the basics, kind of like going from fread to file descriptor. Like, what the fuck? So fread would read file descriptor, right? I guess it would. So this is the start. So we open this, we set this asset, and then the file descriptor is gotten from the asset that was opened by Asset Manager, which this did fopen, and this did fread. Essentially, I think this is what this means. Because yeah, fread has a length, it has a start offset. And then we got this file descriptor FD, and we pass it to the next thing. We just keep passing things around here. This is what makes it so convoluted and annoying. And the audio source. So essentially, just being fair here, all of this opened one file. It was all of this. And that's pretty ugly, in my opinion. Because we haven't even got to the part where, because we could open another file, but first we want to know how to stop the file. So save this as this. And I'm trying to compile Audacity, and I figured out that you need different versions of Qt Creator for Audacity 3 versus 4, and this is Audacity 4. Oh, sorry, 3. And 3, it actually looks new. So it's like sometimes the older version is a little better. These are more commercialized. They've got so many people now on the team. So it's good to keep that old version around, because yeah, they'll just go commercial, they'll get bought out by Google, and yeah, it'll just go to shit. There's somebody. My OpenGL speakers are louder because of my farts. My OpenGL speakers are louder because of my farts. I kind of mispronounced that, but whatever. Yeah, like that pop-up right there, it just pisses me off. So yeah, at least have okay. The next part of the experiment will be to import a sound here, old camel caps lock case, right? So let's see. I love leaving pages like this open. Later it gives me all the cool Google ads. So all the spyware tracking. What did I want to do? Okay. Generator for Goalie sounds. Oh yeah, the key to AI is put the word Hugging Face and GitHub into the name, or one or the other, and you'll find free shit. And then, like, eventually you'll become a Hugging Face meta-er. I want to say Facebooker, but basically, like, there's just, like, so many people that get into this. This is why. And this sort of is on the same topic as the Gemini helping us. But I thought it would, like, do more. Well, maybe it kind of does. It's been generating a little bit of code. But on Instagram, you could also make your own bot thing. Okay, so this just looks crazy. Grodio demo for Matt anyone? Like, what the fuck is this? Stable video matting with consistent memory propagation. I don't know what the fuck that means. Mat is practical human video matting. What the fuck is matting? Target. So I'm guessing it's something to do with, like, materializing video, like it understands video. Oh, input video. Okay, so let's give it some shit. Just feed it shit. Alright, so we got this, like, little video I have. Cool little game. Oh, this will take forever. Okay, Bark, text to speech. Bark is a transformer-based text to audio. Like, and the problem with this is like it wastes more of your time than it would have just me going into this and changing my own voice. I am enfermo mental. I am enfermo mental. Yeah, so that wasn't a good voice change. If I do, like, some healthier things, and my voice will have more parameters. Another asset. Okay, good. If you try to do it back to back, you kind of, and that's the problem. You can't just, like, sit there and make good ones back to back. The AI can, though. Okay, what the fuck does this do? Add mask, several clicks, add mask. Okay, add mask. I don't know what that's doing, but Video matting. It's just like fucking crazy ass shader. It's just gonna fucking drive it nuts. Examples. Oh. The Joker. People just standing in the middle of the street. Weirdos arguing. The Joker being a woman. Alright, I don't know what the fuck this did. Oh, so it does that. That's kind of cool. It's kind of stupid too, but it's kind of cool. Oh fuck. Fuck this up. Yeah, so... Yay. I don't know what it did. It's like the only thing left is the arms. Oh, is it that? Kinda. Alright, whatever. I wanted to show. Okay, this makes you want to barf. Because first you have to waste half your hard drive, and then you get this like stupid ass library. Right wave. It's easier to just go to one of those sound sites. Sound effects generator. Describe the sound effect. Duration. We need it to be like really fast. Prompt influence. Whatever. This will hurry and 15 months. No, it's not what we wanted. Well, there that goes. They're visiting this site again. Stupid flash sale. Yeah, like if you install it yourself, it just basically does what this shit does. They're pretty much similar. It's just like they'll try not to tell you which model they're using, but you could figure it out by just trying all the models on here. Some of these pages, like that one right there, had the example running. Oh, what was it? But you get more influence on these sites to make a good prompt. On these sites, it's like hard to come up with a good prompt. Oh, stupid. Forgot my stupid account name. So what I have to do is just, I hope, yeah, sometimes they want you to get approved or something, I forget. Really? Cool. HaveIBeenPwned.com. Oh, this is kind of cool. Does it give you the actual list? Because you could use this shit with just like a bunch of shit you could download off Google. Like, shit like this. Whatever. Huh. That's hilarious. I already knew that they got owned or something. I was using the passwords from that database to keep like using them after they banned me. Oh wait, I didn't do that. No, I just tried them out. Activision. Oh, this is a good site. This is a good morning site. So you wake up in the morning and you get some good ideas from this. Like, it's good, like, news read. Alright. Stupid bullshit. I have to create a password. I have to do it somehow so no one can see it. I don't know how this is gonna work. It's not. It's like if somebody hacks this account, oh God. Stupid. Stupid tweeter. Your faces, please enter our URL. This is a waste of time. We just need to create a sound. It's not gonna work. Oh, why did I do this? I should have just picked the stupid robot or something. The koala pisses me off, and like all these are freaking weirdo ones. Alright, let's get back to this. No, we have to go back to, okay, realize the player. These breakpoints create these stupid red lines. Get the asset file descriptor. Okay, where do we go? Get interface. Okay, create audio player. Number 4. Realize the player. Number 5, right? Get the play interface. Number 6. Configure audio syncs. So why is audio syncs number 4? Interface IDs. Interface to be requested. Data locator output mix. Buffer queue. Audio lockout mix. Data locator output mixer. Audio sync. the fuck is this doing? Is this a part of... So I have to read a double comment. Don't put a letter right there. Interfaces. Yeah. So, okay, now it makes a little more sense. I was like, the hell? Yeah, because I have no idea what I'm doing here. I mean, I do. I'm starting to remember, but... Alright, 6, get the play interface. 7, get the buffer queue interface. Get the seek interface. The fuck? Let's read the code. Buffer queue ID. This is the seek interface. Alright, so this is something else. There's more than one interface thingamajigger. Volume interface, mute solo interface. So if you're creating a player or like the UI system, like I took it out of the sample. I did it differently. Let's see, search the project for this. All the searches, I'll go import more files. Where's our content directory? Alright, so this is the assets. I have a fart for you, I'm Federal Mental. Can I import two at the same time? I should be able to, I don't see why not. As long as they're not like fucking huge, as like half of, you know, 10 gigs or something. I think it'll be fine. Alright, so we got more files. Is this thing broken? Like, who cares? Okay, go. Like, username is reserved. I could have uploaded an avatar. Whatever, I have to do it later. Stupid avatar. And their email takes like 5 hours to get here because there's a manual like GNOME doing it. Not anyone. So cool. Just don't want my avatar to be kind of stupid. So then I feel kind of dumb. It's like one of those websites where people like judge you probably. Sure, this website has a lot of judgmental problems. People on Hugging Face are like more, not like emo toxic, what do you call that thing? Gen Z. Fucking gaslighters. Like Gen Z gaslighters. I don't know, I'm kind of joking about that, but all those Gen Z gaslighters. You hurt me, so now. What? 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 You hurt me. So now. You're the bad person, because I did that. Alright, finally we get to get free AI with this. This model requires pro subscription. There's pricing on this? I thought it was all free. It's actually not that bad. Compared to all the other MML sites, this is actually very good. Like this is actually doable. Zero GPU and dev mode, but the thing about this is that this is what it is. All these data sets that they're using, all this tech that they're using, it's all here. You could run it on your own. And once you learn a few things, it's not that hard. Basically, if you want to be like safe, you need like I'd say something between a 1070 GPU to a, even though I have to test a 970 GPU, to like a 3050 GPU. Going any higher than that, you're kind of, as long as you have 8 gigs GPU, and it's kind of newer, like there's older AMD GPUs that do have 8 gigs, but they're not really supported on this, or like older NVIDIA ones, like super high end but super old, might not work. But everything that's kind of old and still 8 gigs, it'll work. It's the VRAM, or which called VRAM is a fancy word for video memory. The amount of GD, I don't know, whatever you have. Alright, so sound generator, natural sound generation. How do I download that? Let's pretend we were successful at Hugging Face, or we had the money to pay them, or I have the AI training that I do, but I just don't feel like doing right now, because this computer will run out of disk space, that's what my other computer's for. Do some new, and what you have to do, you sometimes have to install a Windows driver in order to do this. We have to memorize the hotkey for record R. It's R. So what you do is you'll like put 2 windows side by side like this. You know you're gonna hit R, and it's like a little video game. Okay, so that didn't work. And that was kind of expected. And this is why. Recording device, microphone, right? Microsoft Sound Manager input. We got the cat. Oh no, I heard it. I did hear it. But there's no way it's picking up off my earphones, even though it could. There's certain radio devices that can. But you could hear my computer more than anything else. No, that's coming from the earphones, I believe. It's too unloud. Stupid problem. Yeah, I know that there's a way to fix this problem. And this is why this program is kind of good. And you can just primary sound capture driver. Yeah, there's a way to add a loopback driver and record your desktop. Stupid. Whatever. Let's pretend we know how to do that. Yeah, it's that thing. So sometimes it's not there, and it's a pain in the ass to get it to work, but it's possible. Even if your computer is having like all these driver issues on some like clone motherboard, and you don't have all the drivers. So we hit R. The fuck did it record? Ugh, garbage. What's this? Okay, just close this. No. Yeah, there's also a remastering effects, but we don't want that right now. What's wrong? Does it not want us to pirate music or something? That's Napster's fault. Metallica's mad. Ugh, we've broken it. We've broken it by setting it to loopback. Set it back to this. Now it works again. Oh wow. Alright. What the fuck? There was another device. Oh, I think we have to play it into the loopback. Now it works. Now it works. Now it works. Now it works. So that's crazy. Yeah, now it doesn't work. Yeah, that's why you need the older version of the program. It's a little easier in that one. Alright, let's say I didn't know how to do that, but I just, you know, figured out that you can. It's just easy other way of doing it. It's all WAV files. Nobody cares. Yeah, so once you have the WAV file, once you have the WAV file, directory, we want to compress it because waves are a lot bigger than OGGs. And then, sure, this is the funny part. Should go back to the code. But I might go and like do more of the code after I take a break. It's just annoying me. It's like we have to defeat Hugging Face today anyway. From the last time it annoyed me. Alright, so we take our asset. What would this sound like if it looped? Oh, whoops. Hit the wrong button. What was it called? Play or wave? Oh, audio, sorry. What a generic name. It was so generic, I forgot. It opens another instance, that's funny. So export audio. Just annoying it. But nature's sound one. No. Alright, so this is the mistake I made. It is this sample rate. We want the sample rate to always be 44,100 megahertz. 44,100. You want all your files to be the same format. It's a big thing. And basically, your sound mixer is gonna take a shit. It's gonna play some sounds from hell if you get that wrong. And yeah, it's like it's specific to how you set up your mixer in the game, because it's not gonna set up all these mixers and like all those things that we did and like do it like 50 zillion times just so you can support all these other formats. That's stupid. Why don't we just have it all in one format in the first place? It's not a really good looping sound, but whatever. It's good, like you just play it every once in a while ambulantly or throughout the map or something. Alright, this stupid generator. Let's see, did we get our stupid email yet from them? I don't think we did. We're not going to. Text-to-speech, yes.
Kokoro is an open-weight TTS model with 82 million parameters. Despite its lightweight architecture, it delivers comparable quality to larger models while being significantly faster and more cost-efficient. With Apache-licensed weights, Kokoro can be deployed anywhere from production environments to personal projects.
Your face is Kokoro. No code demo.
I inhale farts. I inhale farts.
Alright, so we see that here. I mean, we could do the same thing with Microsoft Sam too. And a few other Microsoft voices, but here we get their voices. So we hit that, it downloads it.
I inhale farts. I inhale farts. I inhale farts. I inhale farts in a demon voice. I inhale farts. I inhale farts in a demon voice.
This one's actually better. Voice US Heart. Bella.
I inhale farts in a demon voice.
I inhale farts in a demon voice.
Zero GPU. Let's see. There's a way to do this. There's a Raspberry Pi project where they do voice changer. But all you really need for a voice changer is speech to text and text to speech, and then you just pass it back. Voice cloning. Select voice. There's an effect, so you slow it down.
I fartet ane dinner. I am professor fart. I am professor fart plese Tommy Bautk again. I am professor fart plese Tommy Bautk again. I am professor fart plese Tommy on Bautk again. I am professor fart plese Tommy on Bautk again.
Okay. This is kind of cool though. Then we could save this in our code. And now we just convert it. Do all that. Alright. Because there's this one. Because the nice thing about, I guess, this. Oh, this is the matrix. So, dude, that's why all this shit was all matrix. It's all these files. Nature's, yeah, so there's a lot of free shit on there. Like weird shit too. Like you could just sit here and play with it all day.
I inhale farts in a demon voice.
Well, that's very like unproductive after a while. Because then you don't get enough sleep over stupid AI bullshit. And then you die. Get the buffer queue interface, okay. So we're trying to get this accomplished. I gotta go take a break because I just need to be off the computer for. It's like annoying. SLID buffer queue. So we have to figure out how to stop it too. So I have to get through all these. Get the seek interface, get the play interface, get the realize player, get the buffer queue interface, buffer queue callback. Because what we need, I think, is the buffer queue callback. And queue the first buffer. Start playback. Yes, this is some go and play function. the play interface. Seek interface. Get the neat solo interface, get the volume interface. So in here we don't have a buffer queue interface. I think we searched for it. Yeah, nothing found. So we don't have a buffer queue interface. And I think it's this BQ player buffer queue. Right. I think we do have it. I could be wrong though. Yeah, so. But it never gets it? Huh, that's interesting. I'll be back. Your LinkedIn Live approval is under review. Okay. I've upgraded to burrito from taco. Forgot I was gonna record. Oh, or make it say. But I've remembered the
add some dependency on AdMob's SDK, for instance, but you don't want to put that on the paid version as well. So you have a different scope. So here we'll have a lot of scope for all your application.
I have to like record that guy and put it into the video game. Make it like that undeprecated content version stuff. Alright, so I have this. The model that I want to take a look at is. Oh, we got an email finally. There it is. So we were approved. Join our organization. No. We have to make sure our queue buffer is calling back. But the queue buffer has not been initialized, so callback function vector. Why am I lost in this? And it doesn't create it like I did, does it? Configure the audio source buffer queue. Let's go back to number 1 for a second here. No, we're not in the same place. Oh no. Alright, so this is the buffer queue. I set some okay, so this is going to be using threads. Nice. Okay, create audio player. 3. What are we passing in here? The engine, the player, mix object, right? No, the fuck. It's number 4. Queue and setup buffer. Getting lost here. Callback function. Wow. So the callback is being set up like all the way up here, I guess. Oh wow. I guess I didn't do this quite right or something. Hold on, let's go back to so every one of these needs to be set up like this. Oh man, I think I did it really wrong. I kinda cheated. I just copy pasted what's in there. Number of buffers 2. Which is bad, but whatever. Buffer size, audio buffer. Okay, so audio buffer. So they have this vector audio buffer thing that I don't have. I don't instantiate this. The buffer size. Fill the buffer with new audio data. Replace this with your actual audio data loading logic. Damn it. This is the hard part right here. Well, obviously this. Okay, so for every instance of, not for every instance of a buffer, but for every instance of doing this void player callback context. And when we do it here, create audio player, we're just creating some stupid object thing. Damn it. Okay, audio source. What is audio source in this? Audio sources are a little file. So there's multiple things happening here in both worlds. In this instance, they're setting up a 2-buffer thing. This is where it gets confusing. Here all they're doing is in correct initialization. This is why coding with AI sucks. So it gets like this complicated. It's easier to get lost. And then like it's better to look at an OpenSLES example for like a game engine. And there's some stuff I looked up. I have to go look at that. That's why I want to kind of jump into the map editor real quick. Or the scrolling. Do that and then put this into a class. And this has to be like wrapped around and... Okay, so... Realize the player. Buffer queue. Audio source is equal to, here the audio source is equal to that file thing. Format meme, data format meme, container unspecified null, meme type. So it's not even specified here, it's just like, well, we know that it's going to be, whatever you call it. What's this file name called? Oh, I don't have access to recent files. That's unfortunate.
I am professor fart plese Tommy onbout again. I am professor fart.
Okay, let's see if we can do an MP3 version. Before you had to install some special plugin into Audacity to do this. Now they might have fixed that to where it automatically... Yeah, it looks like they fixed it because I see the other file. Since the name of this file is like some gnarly name. Yeah, temp blah blah blah. So to export MP3 you had to do some stuff.
I am professor fart plese.
You had to install FFmpeg and compile it into this library thing. And so OGG is OGG verbose files. That's what it's called. Okay, so oops, wrong project. Put that in there. So basically this is saying that the audio source or the audio file is what's in the buffer. So what we're going to have to do at some point is copy this audio source from this assets that we created and put it into the buffer file. So we're going to have to do some buffer copying. Oh, this is going to be a debugging nightmare. So let me see something. Can we do this in C++? problem. There's OpenSSL, which is a secure socket library that looks like OpenSL. This is an interesting answer. This audio track API. Yeah, so playing sounds on really old devices problems. The audio is smaller and easier to use than OpenSL OB examples. Let's grab this real quick.
Many apps use audio to create amazing experiences. Whether it's DJing, karaoke, or musical games, audio is a powerful tool for expression, entertainment, and creativity. Today, I'm going to show you how Oboe, a new C++ audio library, makes it easy to build interesting, interactive audio experiences on Android. But first, what do we mean by interactive audio? Consider this keyboard. I press a key. The keyboard makes a sound immediately. This makes the keyboard feel incredibly responsive because I get instant audible feedback. It's part of what makes playing an instrument such a joyous experience. But imagine if after hitting a key, I had to wait to hear the sound. This delay or latency would make the keyboard difficult and frustrating to play. The same applies in apps and games. Whether it's rhythm games and karaoke, DJing and scratching apps, virtual reality, synthesizers, drum machines, and other virtual instruments. All these apps share the same common requirement. They need low latency audio to provide a great user experience. And that's exactly what Oboe does. It's a C++ library which makes it easy to obtain the lowest possible audio latency on any given Android device. It works with API 16 and above, which means it's compatible with over 99% of Android devices. Under the hood, it uses A-Audio on API 27 and above, falling back to OpenSLES on older API levels. This way, Oboe provides a single, easy-to-use API which takes advantage of the new features and better performance in A-Audio while still providing backward compatibility with older devices. To get started with Oboe, all you need to do is clone the repository from GitHub. This will copy the library to your local machine. Oboe is designed to be built as a CMake sub-project. To build it, you need to update your project's CMake configuration. If you don't have an existing CMake configuration, you'll need to add C++ support to your app by following the link below. First, tell your project where the Oboe source code is. That's the path to which you cloned the repository. Next, add this path as a subdirectory and add the public headers. Finally, add Oboe as a dependent library. To have Android Studio index the library, go to Build, Refresh Linked C++ project. Now that's done, you can use Oboe objects in your code by including the Oboe header. All objects are in the OBO namespace, so they won't clash with any other namespaces you might be using. Now you're ready to start using the OBO API. Check out the Getting Started guide, the code samples, and the code lab, all available on the GitHub site linked below. If you have any problems or questions, please post them in the issues section on our GitHub site and we'll do our very best to help you out. You can learn more about OBO, including how to create low latency audio streams and a high priority audio callback in the next video in the series, Making Sounds with OBO. That's all for now, so good luck and go make some noise.
So I guess this is the easier way to do it.
Low latency is when creating interactive audio experiences. But how can you actually achieve this in your app? In this video, I'll show you how the OBO library helps you to create a low latency audio stream for playing sound.
Alright.
To a number of different audio devices, such as the built-in speakers, wired headphones, USB audio devices, or over Bluetooth. An audio stream is used to move data from your app to an audio device so that it can be played. To create an audio stream, we use an audio stream builder. This allows us to set properties on the stream. It's best to leave most properties unspecified to allow OBO to pick the optimal values for the default audio device. However, to create a stream with the lowest possible latency, there are a few properties which we should always set. The performance mode should be set to low latency, and the sharing mode should be set to exclusive. Once the stream properties have been set, we can open the stream by passing a reference to an audio stream pointer. Be sure to check the stream opened successfully, otherwise you won't have a valid stream object. If there was a problem, you can convert the error to a human-readable string using convert to text. In fact, convert to text can be used to convert many OBO objects to text. Once the stream has been successfully opened, you can start it asynchronously. You can now send data to the audio device. To put data into an audio stream, we can either write directly into it or have the audio stream request data using a callback. Callbacks give us the lowest latency, so it's best to use them for interactive audio apps. To create a callback object, subclass audio stream callback and override the onAudioReady method. This method is called when the audio stream requires more data. It has three parameters: a pointer to the audio stream object, a container array, which we can write our audio data into. This has type void star because the format of the audio stream can either be 16-bit integers or floats. It's up to us to cast to the correct format. Lastly, numFrames tells us how many frames of audio are required. Each frame contains one or more samples. The number of samples will depend on the stream's channel count. For example, the stereo stream has 2 samples per frame, one for the left channel and one for the right channel. numFrames also tells us the maximum time we have to create the data. Failure to supply data within this time is known as an underrun. As an example, if our audio stream has a sample rate of 48,000 samples per second and 192 frames are requested, this gives us 4 milliseconds to create this data. In the real world, we want to keep well under this deadline to allow for system overhead and late callbacks. To give you the best chance of meeting this audio deadline, onAudioReady is called on a high priority system thread, which means it won't be preempted by lower priority threads. But it's critical that you don't do too much work or block inside this method. More detailed guidance on what you should and shouldn't do here can be found in the full guide to OBO on GitHub. Inside onAudioReady, we write the requested number of audio frames into the audio data array. This could be generated using digital synthesis or be supplied from pre-recorded audio data. Finally, return a data callback result. This can either be continue, which indicates that we want the callbacks to continue, or stop, which indicates that the stream should stop with no more callbacks. Once you've finished creating your callback object, you can link it to your stream using the builder we created earlier. There's one final step we need to take to ensure our audio stream has the lowest possible latency: setting its buffer size. The audio stream's buffer size affects the time it takes for an audio frame to travel through the stream to the audio device. The larger the buffer, the longer it takes, and the higher the latency. An optimally sized buffer provides a good trade-off between latency and underrun protection. The
buffer size must be a multiple of the stream's burst size, which is the number of frames that the audio device consumes in a single read. A good rule of thumb is to use twice this burst size. This means that if occasionally we miss our audio callback deadline, the user will not hear an audio glitch as long as the next callback runs on time. Use get frames per burst to get the burst size, and set buffer size in frames to set the buffer size. Now that all the stream properties are set, we can start the stream. Callbacks will start immediately. And once you've finished with the stream, remember to close it. After you close a stream, it cannot be accessed anymore. You should now have everything you need to play audio using a low latency audio stream. For a working example, check out the Hello Oboe sample on GitHub, which shows you how to create a simple synthesizer app. It also demonstrates how to handle audio device changes, such as when the user connects their headphones. A link can be found below. In the next episode, I'll show you how to record sound through a microphone using low latency input streams. That's all for now, so good luck and go make some noise.
What the fuck?
In the previous videos, we've seen how the Oboe library makes it easy to play low latency audio, but what if you need to record audio? In this video, I'll show you how to set up low latency streams for recording. Recording audio is done in much the same way as playing audio. The main difference is that our audio stream moves data from an audio device, for example the built-in microphone, rather than sending data to it. Before creating an input audio stream, you'll need to make sure that your app has acquired the record audio permission. To create the input audio stream, we use an audio stream builder, setting stream direction to input and the performance mode to low latency. Now we can open the stream by passing a reference to an audio stream pointer. After checking that it opens successfully, you can start the stream. Data from the default recording device will start moving into the stream. There are two ways we can read this data, either directly or using a callback. Data from the default recording by passing a reference.
Alright, so learning how to do something harder sometimes will help doing something easier.
To create the input audio stream, we use an audio stream builder, setting stream direction to input and the performance mode to low latency. Now we can open the stream by passing a reference to an audio stream pointer.
Wow.
After checking that it opens successfully, you can start the stream. Data from the default recording device will start moving into the stream. There are two ways we can read this data, either directly or using a callback. It's possible to obtain the lowest rate to block the current thread. So, let's say we wanted to read 2 milliseconds of audio data from a 16. To create the input audio stream, we use an audio stream builder, setting stream direction to input and the performance mode to low latency. Now we can open the stream by passing a reference to an audio stream pointer. After checking that it opens successfully, you can start the stream. Data from the default recording device will start moving into the stream. There are two ways we can read this data, either directly or using a callback. It's possible to obtain the lowest latency using both approaches. I'll demonstrate how to read directly from the stream since the callback method was covered in the previous video. The method we need is unsurprisingly called read. It takes 3 parameters. Buffer is an array into which the audio data will be read. Num frames is the number of audio frames to read. And timeout nanoseconds is the maximum number of nanoseconds which the method will block for. If you specify 0 here, the method will return immediately, copying only the data that was currently available in the stream's buffer. This is useful if you don't want to block the current thread. So, let's say we wanted to read 2 milliseconds of audio data from a 16-bit mono audio stream. We can do this using a blocking read. Start by creating an array to store the frames of audio. The amount of data we need to store will depend on the stream's sample rate. The timeout should be longer than the amount of audio we want to read. In this case, we'll use 3 milliseconds and convert it to nanoseconds. Incidentally, Oboe provides a number of useful constants for working with different time units. Before we can read from our stream, we need to clear out any stale data which might already be in the stream's buffer. To do this, we just perform non-blocking reads of the whole buffer until it's empty. Now, when we read from the string, we know we're reading the most current audio data. After read is completed, we need to check the result. If it was OK, then result.value will contain the number of frames which were copied into our buffer. To read more data, surround this block in a while loop. This approach allows us to process small buffers of up-to-date audio data for processing and moving elsewhere. After we're done, we must close the stream, and after a stream has been closed, it can no longer be accessed. This is a very simple example of how to record audio. For more complex examples, including how to implement synchronous recording and playback, check out the live effects sample on GitHub. You can also check out the other videos in this series. The first video is an introduction to Oboe, which shows why low latency audio is important. In the previous video, we saw just how important low latency is when creating interactive audio experiences. But how can you actually achieve this in your app? In this video, I'll show you how the Oboe library helps you to create a low latency audio stream for playing sound.
Oh, that's how you do that. It's easier than I thought. Okay. So this is the other version of the game. We're back to this. We could load the OB samples, but I bet you that they don't have the. They might have the OpenSL source code. Okay, let's try this. Did we overwrite it? No. Okay, good. Alright, this will take a little while for it to kind of... Sure, whatever. Soundboard, rhythmic game. Interesting. Alright, so we got all this WAV file parsing in this one. Audio device. So can it detect USB audio devices that you have connected through a dongle? I'll just search for that for now. So the way I implemented was actually the harder way, but it can't go back a certain API. But the amount of back you can go with the other API, like, it's better to do it with this API, and here's why. Because if you're making a cross-platform game, this is the best interface that's going to look like OpenAL. Because on PC, OpenAL, I think, looks just like OpenSLES. So this is really the question I should have asked. OpenAL is a widely adopted royal-free library with GL-style API extension and mechanisms, similar to OpenGL. OpenSLES is a royal-free cross-platform hardware-accelerated C language API for 2D and 3D audio. While OpenAL is closed proprietary, OpenSL is open source. So what's the best cross-platform audio lib these days? Is OpenAL still relevant? So it says open in the name, but they said it's closed. So I think it was open at some point, then they closed it, thinking that they were gonna make money off it. Oh no, yeah, and then look at all these libraries. Pick one. Oh, this is a good thread. This is a really good thread. So yeah. Maybe I didn't know what I was talking about, but yeah, this kind of tells you how guerrilla this is. Yeah, I've seen this RT audio also. So I kind of answered my own question here. I can answer this question by reading up on what I was doing. But I'm still going to ask it anyway after a little while. And cue the first buffer. Start the playback. Register the buffer queue callback. Alright, what does this end? Ugh, ow. Fuck. Nothing found. Alright, this is building. So it's getting happier and happier. Gradle was like wrapping it and unwrapping it and parsing it. It's Megadrone. Which one should we play first? Rhythm Game or Megadrone? Megadrone sounds cool, but Rhythm Game sounds... And there's also Soundboard. Rhythm Game is already selected. Let's go. So audio is practically like graphics when it comes to difficulty and the amount you could spend time into it. But for our intents and purposes, we're going to stick to a 4 audio channel, if possible even, and just have it work. Because some of these other libraries will have 8. Well, I think all we really have to do here, let's go back to this. So this does INIT sound, right? So what I would have to do is rip out play sound. And so yeah, so this would be like this. I just want to kind of, but avoid results. So it does the same thing. Paused playing, is playing, pause playing, is playing, playing. Okay, so it just sets it to playing. Alright, so that's that. Alright, we can kind of break this down. Almost makes me want to start a new project. Well, we did copy this project, so if we screw this up, we might as well. Might as well start now. What do we need to load a sound? We need the asset manager. just need this, right? Okay. Ugh. Then we need to take some other sound. Oh. How do I copy the name? Copy path reference. No. Ow. Whoops. Copy path reference. Absolute path. File name. There we go. That's how you do it. Put that in there. Let's load this sound. And where does it end up being? It ends up being this audio source. Right. Left and 360 degrees. Alright, so then step number one, back to step number one. Now back to, let's go all the way back to this. So we have this defined, right? We have to define this where we define this. Okay, so we define this and render it as C++ up here. And we're going to define this number of buffers, 8. I said 4, but whatever. Is this going to be enough? Well, we're going to have to times that by the amount of 8. So, we could allocate a megabyte. Calculator. Two to the power of 32. No, 2 to the power of 8. Let's see, 2 to the power of 8. Oh, stupid standard. Why? Why did it reset everything? 256. What does that mean? That doesn't mean much. Times 8. Okay, that's nothing. 496 times 8 is equal to 16 kilobytes. Okay. Save battery life. Okay, fine. Let's use this number. Alright, so that's done. Now we need to function callback. What is this function? Can't read it. I should just make more space. It likes to auto scroll. Create audio player. Alright, so we've defined that. Alright, so this is how it starts. Audio cue, BQ context. Number of buffers. Alright, so this is our callback function. when we already have one. Alright, so this one's a little different. This one is the one I took out of the sample. What's wrong with this one? How are these two different? Okay, buffer size. NQ audio buffer data. Buffer size. So I don't trust the AI on this one. I'm really having trust issues because okay. Every time the buffer finishes playing, go the next thing. Well, it's not the no is not the next buffer. Next buffer. So it does this. So once it's done, dang it, this is the really confusing part. Like, what do I do at this point? Alright, so this just releases the buffer. Create resampled buff. Might have not need some of that stuff up there. Some of this is already done here for us. Okay. Now what we're gonna do, we're gonna go open I think we need to open this. Could be wrong though. And then create player. So buff your Q call stack. Basically, so this does create audio player like this. A player, data source, data sync, number of interfaces. So it passes 3 interfaces in there. Okay. So it does call this number of interfaces 1. So I think we just need to register. And Q next buffer. Where is this next buffer coming from? Oh. So where do we take this from? Yeah, we took it from here. This is kind of stupid. You see the log for details, damn it. This is dumping garbage. Garbage collector. How big is this already? 100 megabytes, just garbage. What's in here? Oh god, just a bunch of stupid ass Kotlin shit. Oh wow, it's producing a lot of garbage here. Oh, this is a nice folder to know about. This is okay. God damn it. Oh, no. Yeah, I guess it doesn't let you do that. You gotta... Did it crash? I believe it crashed. Wow. Wow, okay. So this example isn't very good. Something we were doing was better. Okay. So let's try this. I'm gonna go with Bard on this. And gosh darn it. Oh. We'll just do it. The oldest trick in the book. Set that up. We'll just do this. I don't know why I keep slacking off. That's done. Because we didn't really even register this callback, I believe. Let's do it like that. Now the question becomes, how do I call this audio player? Shit. Call create audio player after creating the output. Okay. Create sampler buffer. That's some older shit. Uh-oh. Explanation, global variables, player object, player play, the audio player object, BQ player play, the play interface, BQ player buffer queue, the buffer queue interface, buffer size, the size of each audio buffer, number of buffers, the number of buffers in the queue, audio buffer, a buffer to hold the audio data. BQ player callback. This is the callback function of OpenSLES that will call when a buffer has finished playing. Fill buffer. You must replace the example code with your actual audio data loading logic. Enqueue. Then enqueues buffer again, ensuring continuous playback. Create audio player. Configure audio player source. Data locator audio player defines buffer queue with the data source. SCL defines audio format, stereo, 44.1 kilohertz, 16-bit. Data source obtains locator and format. 2. Configure audio sync. SD data locator output mix defines the output mix as the data sync. SL data sync combines the locator and format. 3 interfaces. SLID buffer queue requires the buffer queue interface. Create player. Pointer start engine. Create audio player creates the player object. Realize player. BQ player object realizes the player. Get the player interface. Get the interface from the SL play. Cut it off. Okay. We have to go to this page. Audio player, audio recorder, engine, output mix. Bass boost, yes. Audio player, audio recorder, no. Engine, no. Output mix, yes. So you could remix it. Alright. I think I did it like this last time where I asked the AI and it gave me bad examples and then they just copied it. So I'm kind of going in circles here a little bit. Discord bar to update how to play audio. What? Create audio engine and output and mix. Okay. Create audio player. Damn it. Right, so it's kind of gives us the same code. Okay, so create audio player. Alright, so it's kind of telling us if we copy paste that bloat of code. And we just kind of comment it out. Okay. passing in 1 here. Oh, so we did this before. First we create the sound engine, then we NIT it. I did kind of did differently this time. So we have to comment that out. And we have to go see what's in there too. I think it's the same thing. Yeah, it kind of is. Uh-oh. Getting like convoluted here. Ah, the code snippet was blocked. Regenerate. Damn it. Stupid generator by AI. Oh, this is kind of like the specification I was reading earlier. 1.1 specification. I was reading 1.0. Alright, where does it say load sounds? Scope, intended audience, brief history, page, blah blah. Objects, interface, guiders and setters, representation code. What kind of speed reader do we need to be to get through this on time? A little better than the AI you actually get. We got the music audio player. Then we have a use case where, I don't know if it's this one or not, but it's some other one. Where you would have mic communication. I'm not reading some of these as little ones. Saving that. Read through this. Gonna go take a break. I'll probably do the map offset thing. Just get this to run. It'll probably crash after I did those mods. But I kind of on my own, I think. The way I think I'm going to do it. I'll just copy paste the function. I'll try to playback new sounds result if there's nothing. Oh, yeah, this should be that. What's the thing? Okay, so when you play a sound, What do you specify? A buffer? Okay. This will play. It's Q player play. BQ player play. Set PlayStation BQ player. Right. Alright, so I don't think we need this one. Oh no. Or was it? Alright, so create sound engine, blah blah. Load sounds, blah blah. Create audio player. Create audio player. And there's this. Wait a minute, let's step back here in a second. Okay, but we're going to be calling this one. Num-buffers is used here by him. Let's look at INIT sound old. Does he call this function? This function is lock buffer kill. It gets passed into audio source. Alright, this didn't grow, so that's good. This is how you do it, okay. So this is getting interesting. This is how we're copying the buffer over. Recorder buffer. IDX return null. Fuck. If I click here, it crashes it. And my log file fills up. So I'm not allowed to use this. Oh. Something bad just happened. Let's try this again. No. It crashed the first time. A rhythm game. I have to follow along with. Alright, so it like... Fuck. Yeah, fuck you. I don't want to do that. Alright, what it's telling me to do. Oh, this is terrible. I knew this is something so stupid. It's kind of stupid. So you hit the screen and it makes a different, like, generated sound. Drum thumper. Actually, I wanted to do soundboard or make a drone. Yeah. Let's do make a drone. Then I'll go take a break. For the for our art project, I believe all I gotta do is copy the buffer like the sample does. I mean, you can do here, sample buffer, shadow cue. Oh, this is the audio player, but in the other one, in our native. Oh crap! It did it, but I screwed up. Yeah, because they're embedding the other ones, the other buffers. And when they do that, face one. Oh. Yeah, so they're creating a recorder here too. So we can do recording too. But it's like advanced, but who cares? Alright, let's hit this again. Yeah. Tap anywhere to play. Alright, so it makes a weird sound. Let's see what it actually does. Besides destroy your phone. Alright, builds audio stream builder. So is there only one sound? Like, this is dumb. What else? So it's synthesizer, mega drone engine. So OBI is kind of similar to, I don't understand why they use it if you just use OpenSL. It's like, it's gonna become obsolete. That's my opinion. But OBI is built on top of OpenSL, so it's kind of like a preference thing. Because their use cases are better on OpenSL than OBI, I think. OBI is just kind of a little easier on these samples, sending the sample in. I think I'm just a noob. Alright, soundboard. One more, fuck it. One more and indicate samples. Yeah, so when he does create audio recorder, yeah, so he creates an audio recorder and a player. Start recording. So I'm kind of learning by the matter of fact that I'm not doing shit. I'm just browsing around. I hope so. I should actually just be reading the documentation or doing the OpenAL example in C++. It's just faster workflow than this. But Android workflow isn't that slow once you're good at using Visual Studio. Okay, so soundboard. This is kind of cool. Oh, it crashed. I think. Did it? Yeah. I tried to press too many things because you can press like 5 buttons. It doesn't log. It doesn't let go when you use 5 fingers. Oh yeah, it does after you recycle. That's pretty cool. You could play the chord just by scrolling your finger. I actually like this one a lot because you could synthesize the sounds and make your game sounds based on like these like grid synthetic these and kind of mix them up based on the grid. Based on the timings, you just time and record the timings and then play them back. Yeah, just make this an app. Just put ads on the bottom. That's all you need. Wow. That's so easy. I bet they have a bunch of soundboard apps. I don't even know. But anything that's easy usually is already done. So what you need is this soundboard and play music in the background. Alright, let's get back to our little... Alright, let's just compile this. Let's see what's broken and I'll fix it. Set up buffer queue. And then we'll set up our loader somehow. We'll figure out how. It just has to, you have to get the data out and have to just go. Oh god. What's wrong with this? It's always good when you can spam your keyboard into a window. It means it really got locked up good. Oh yeah, look at that. It's just like a really long IE Explorer page. IE Explorer is always going to be IE Explorer. That's why it's IE Explorer. And then Chrome will turn into IE Explorer eventually. Alright, so we're going to type in here the thing that we want. Multiple audio files and load into buffers in C++. And let that cook. Okay, so it seems it rained just really hard all of a sudden. Play sound. So declared new. No, we fixed this. What the hell? Devices are running. Ah, shit. Stop. The buffer is fucking barred, dude. Oh my god, he just... So when it plays the sound... Because of this. And what's it playing? We should break right here. I mean, we should break earlier than that, but I think I don't know if I put breakpoints in the new function, but I know I put it on the callback. Alright, come on. Get your shit ready. What's it doing? Local intimate failed to connect the socket. Fuck. It's not good. Alright, let's stop. Stop. Stop all. Damn it. I don't think that was a good idea. Now we lost it. Can we run it again? Yeah, we could run it again. Uh-oh. Debugger cross release code. Rerun app. Fuck. We broke the debugger. What did it say? Oh shit. You're garbage. Unable to start debugger session. All this shit doesn't make any sense. Oh crap. I don't know how to fix this. Alright, let's fix it like that. Alright. So we're back. Okay. Let's try it again. No. Can't do it that fast, sorry. Okay, let's try it again. Starting Gradle Daemon. Fuck. This takes forever. Alright, so we have to... Okay. It's just filling it with garbage. For size is 16K. Alright, good. You're connected. Now sometimes you can run into this error and the best thing to do is just restart Gradle Studio. I mean Android Studio, sorry. So we did hit the callback on the playback. This is where he's filling the buffer with garbage. And so let's step through it. We're in the garbage phase. It's generating, evaluating, okay, it's just some shit based off the remainder of I. Loads and variables, okay. It shows what I is. I is 2. Okay. So perhaps we went through all that crap. And audio buffer 1. It's a vector of 4. So, in Q, take the buffer audio data. Again, what's an audio buffer? Buffer size, char. We should have loaded the sound, right? Play sound, okay. How do I close this shit? Okay. Made that crazy sound, it came back. Made another crazy sound. And it just, now it's frozen. Again, on the callback. Alright, so it makes the sound for like a second. Alright, let's stop. I think the best way to kill this without having to restart Android Studio is to do that. Just exit the program, and then we've disconnected from the debug with the debugger by not fucking us up. Okay. Now that we learned how to do that, is play sound 1. Okay, so play sound 1, is that the one we're calling? How are we calling play sound? We should be calling play sound 1 somewhere. No, that's not how he's calling it. He's just calling it. Right? Yeah, so we need to display that OGG mess. So when we initialize the sound, how do we initialize the other sound? When we initialize the sound, okay, no. We need to load the sound. Play new sound. Play sound. Damn it. Okay. So play sound is the one that I call sound to play. But where's our fucking loader? We don't have the graph thing, do we? I have to search for OGG. Okay, so this is the one that loads my other sound. Once we load the asset, that's all we get. Okay, we know it's in there. Alright, so well, it's initialized. It's a great sound engine. It used to be called here, so we call it INIT sound. Right. So we need to call load sounds. Let's load the sounds. Then we will Ask Mark what to do. Which would you like to do? Okay. Okay, specific code and C, copy my buffer after calling this. And we want that sound z. Okay. Now we want see what kind of madness it generates. I mean, my opinion would be just decode the sound into an array sound map file. Storing sound map. Oh shit. STD move. No, I don't want to do any of this. Oh god. Is this going to be like 50 lines of code? Sound data iterator. Play sound file name and sound. It's sound state play player. Sound data play. So it wants us to do this. Okay, fine. Let's try this. Even though I doubt it'll work correctly. Always fix it later. Alright, so we just initialize the code. Source and be resynchronized. We create another audio player. Realized it. Got the interface. What is sound data? Alright, so we did all that. No, wait. Where did I ask that question? Damn it. Oh, here. Okay, this is what I copied. Alright, so I did copy the sound data thing. So it'll call load sounds. The asset manager will go fetch my two sounds, sort through them. Read them, close the asset. Oh, so it's going to use asset read instead of using that other thing. Move that into sound buffer data. Set its buffer stuff. load it into the sampler, or I mean Android buffer queue. The audio source. Okay, how is it sound data? How is it picking which sound to play? Alright, let's just run this. Oh yeah, sound data equals iterator second. Alright, some STD map. Damn it. Scrolls too fast. Sound data. Vector fstream assert. Why did this collapse? Android Asset Manager. Interesting. This uses verbose file.h. Under decode OGG file. Okay, yeah, so it has to decode it. I'm reading another sample. The same type of ideal thing. Create player. File names, create player. So it creates a player for each file. GitHub assistance. System Android base. Altonia. Alright. It's only 1,000 lines of code. I could have looked this up on Google. Oh, I could have guessed this too, but oh. The other two, I believe, are already included. Okay. Deprecate. Click. I want to leave that for antique purposes. Alright, so we know what the problem here is. Play sound, okay, so it maps it. It uses the map as the hash table. What if we just do play sound now? Figure that out in a second. It's probably gonna make the crazy beeping sound still. Comment that out. Oh god, no. gotta figure that out. Do we fix it right away, or do we, like... Alright, where's our fucking thing? Which one is this? It's right here. This is the thing that's causing it. So instead of this, right, it's called play. What the fuck? Let's try. Why is it not happy? fucked something up when it's giving these really gnarly errors. You will die. Yeah. Of course, so like, what the fuck? Oh, we're inside this. This is why. That's not too bad, okay. Who cares? This is the thing I'm worried about. Okay. Blah blah blah. Does this establish a Q callback? So, for example, and this is when the player moves backwards, I think. So when he jumps, he moves backwards. Alright. I don't hear anything. Well, yeah, we have to do the update loop for next. Damn it. So, I think this is the problem. We're just hallucinating shit. This is for sure gonna crash. I have no idea what this is going to do, but I think this is getting to the right stupidity. So it'll call this with that object in it and attempt to play it. The buffer audio data is going to be data. It should play the beeping sound, theoretically. Oh no, wait, it's not being set to anything, so it'll just play zeros. We'll find out. Okay, that makes no sound. What the fuck? Okay, no. I think I failed. No, no sound. What would you like to do? Destroy you? Doing this to me? I don't think I did it the right way. We'll see if this callback gets called. Alright, so it does get called. Wow. So the playback has to be started by this, right? It didn't stop there? What the fuck? Alright, pressing a button. Okay. So, play sound got called, right? Sound got called. Farts. Create models 5. Handle input. Okay. Play state. Player play state. Player stopped. Your state equals playing. Player stopped. We want to know if it hits this line. Oh, and repeat. This is how it's doing it. I think I fucked up that code. Alright, so when the okay, maybe we need to remove this. When the callback hits, we have to stop it, I guess, or when it finishes or something. Alright. Oops, I didn't have this running. Oh well. Yeah, this project needs to be restarted from scratch. And the entire project, I think, really. Alright, so it's not playing anything. Create the queue, calls the callback, creates garbage. Set player play stopped. Why is this here? You might need this. Right, so that should be telling it to play, but it's not. Why not? Alright, if this doesn't work, I'm just gonna go take a break. I mean, I'm just gonna do this later. I'm starting to get the hang of it. I just need to watch like more hours of videos on this. Alright, so it does call this. I don't know why it's calling this buffer thing first. Well, we know why. NHE sound. Create player does this. The way this is doing it. Oh, because it's gonna use this object twice, which is bad. It's gonna use this BQ callback and attach this queue to it. Alright, whatever. So this is manager equal to something? Yes, it is. File name, what's in file name? So I need the buffer, the size. This should be. Oh, we want more than one buffer. Okay, whatever. Figure this out later. So I loaded it, I guess. The sound map is not being mapped. Why? Why is this sound map left work? Continue, return. Okay, these are 2 places where it can fuck it up. We'll just find out. Alright, it should be here that it fucks up. Alright, so this is garbage, there's some garbage. What's the sounds? Where are we? Okay, whatever. And get the buffer queue interface. Return. Result is not equal to success. Chill player buffer queue. Alright, that's because with this. It's because it's already been set. Okay, that makes sense. So what happens is it exits everything before it even gets a chance to map it. So because the other shit is just garbage. Okay, let's build it first, then we'll debug it. Seems to work that way. Socket. Step through this. Fuck. So. Sound data flare object. What's our variables look like? Result 12. Request blah blah blah. Wait a minute. Okay, result. It's not equal to 12. Okay, 0 means success. Okay. Why is the result 12? Okay, buffer queue, player object. So this is when it calls error getting buffer queue interface. Static. Alright, that's the global one. We don't really need that one. Get deployable for Qt interface. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Feature unsupported. Alright. one more time. do this later. Even the debugger's tired. I screwed it all up. I got confused. And it's not the right code. I kind of get it though. You have to just copy these buffers over. I have multiple buffers. I don't know if you're allowed to have multiple buffer queues. But basically what I should have been doing is trying out all, well, I just need more time. Should have been reading this obsessively. I'm just going to go read this. Because the NDK sample doesn't seem to be that great either. It's kind of good. It'll get me through, but I think there's more to it than that. And then I can address music and a few other things. It's better to do this a little optimized. And then maybe try the other libraries, AA and OpenSLES. Maybe the other one too, but oh, I should have taken a look at this.